All right, this is Honors Pre-Calculus, Chapter 2.1, Functions. So what is a function? So I just need to let you guys know that function is not equations, okay? I can give you an equation and ask you guys, is this a function? Okay, so the test you have to use is called the vertical line test. So let's get started with some homework problems. So number 32, if I ask you guys to graph the equation y equals to x cubed, so you're gonna graph it like this, okay? Here comes the vertical line test. You guys have seen it in Algebra 1, hopefully, if you remember. So you're gonna have to draw lines like that. These are the vertical lines, and we're going to be performing this test. So if you guys have just one point of intersection for each line test, or I should say for each vertical line like this, okay, then this is a function. Okay, I should say yes, it's a function. Okay, so let's look at the next one. So number 32, I'm gonna graph it a V shape. Okay, using the vertical line test. Okay, so each vertical line only has one point of intersection. So yes, this is also a function. Okay, so let's move on to the next one. What about this one? Looks tricky. So this is how you're gonna graph it. So the way to graph this one is that you guys gonna have to set this equal to 0. Okay, so 1 minus 2x equals to 0, and you're gonna solve for x, so you know where the function is graphing towards. So we have 1 equals to 2x, so x equals to 1/2. So if I call this 1, it's going to shift towards the right by 1/2. Okay, now let's talk about how this looks. So positive square root is going to give you something like this. So start from the 1/2. You're going to have something like that. The negative square root is going to give you something like this. Okay, so which means that this is going to be your function. And if you perform the vertical line test, see what's going to happen. You got 2 points of intersect for each vertical line. Okay, right here, right here, right here, right here. So this is not a function. Not a function. Let's go on and move to the next one. So this is so first of all, subtract y squared on both sides. This is going to be a similar graph as the previous one. So x equals to negative y squared plus 1. So in order to graph this one, okay, so understand that this is going to be the x-intercept. Okay, and then you know that this is going to cause a reflection. So the way to do it, you know that this is about to be, okay, you gotta reflect first. Okay, so it's gonna look something like that. Okay, and x-intercept, so move towards right by 1. Okay, so it's gonna look like this. So if you put the vertical lines, you guys gonna see that, oh, I have 2 points of intersect. So not a function. All right, so let's move on to the next one. Now, we're gonna be talking about the function that we're gonna be substituting 0. Look at this. This is f of x, right? Now I'm asking you guys to solve for f of 0. So what you're gonna do is understand that this is basically telling you guys to subbing 0 into x. So let's get started with this one. So 0 squared minus 1 over 0 plus 4. So that's gonna be negative 1 over 4. Okay, so next one, you're subbing negative x into x. So every x is going to become negative x. So it's going to be square of a negative negative x minus 1 over negative x plus 4. Okay, so we have x squared minus 1 over negative x plus 4. Okay, so let's look at letter H. I'm skipping on letters, okay, because I just focus on the ones I think is more important. So look at the next one. So you're gonna subbing x plus h into the x. So x plus h squared minus 1 over x plus h plus 4. Okay, so what you're gonna do is that you have to FOIL and multiply this x plus h squared out. So that's gonna give you x squared plus 2hx plus h squared. Okay, and then subtract 1. Don't forget about that one. And then on the bottom, just remove the parentheses. So it's going to be x plus h plus 4. Okay, so that's it. All right, so there's a topic about domain and range. So this one on the slide, let's talk about domain. Okay, I hope that I can give you guys an explanation that it's understandable. So first of all, draw the x-axis and the y-axis. Okay, so domain is about x-axis. So let's get rid of that vertical line, which is the y-axis. So here's the x-axis. Okay, so domain is basically tells you how much ground. When I say ground, I mean the horizontal. Okay, the horizontal distance. So how much ground is this function covering? Okay, so for example, if I said y equals to x plus 1. So how will you graph this one? Okay, so in order to graph this one, if I just put out an imaginary y-axis in order to graph y equals to x plus 1, I'm going to okay, don't worry about that imaginary y-axis. Okay, so I'm going to erase it because I want to just focus on x-axis here. So you're going to have to start with the y-intercept. So that's 1. Okay, you're going to go up 1, right 1. So this is how your function looks like. Okay, on the x-axis, because there's two arrows, there is an arrow on each side, so this is pretty much extended to the endlessly. Okay, on the domain, you're basically covering every single value on this x-axis. You see that it's going left and right endlessly. So your domain in this case is going to be all real numbers. Okay, so all real numbers for your domain. All right, so this one I'm going to talk about range. So range, you want to think of it as, see, earlier I talked about that there's a x-axis. Oops, I should draw the y-axis and the x-axis, right? So now when we're looking at the range, you want to ignore the x-axis. You want to just focus on y-axis. Bring out the same equation as before. So y equals to x plus 1. So remember earlier, I got something like that. Okay, so this one you pretty much cover. See, look at this arrow right here. It's going down endlessly. Look at this arrow right here. It's going up endlessly. So this is pretty much gonna cover all the height of the y-axis. So here is my explanation for the range. It's how much height the function is covering. Okay, this is an unofficial explanation. This is just with my own words. If you don't understand what I just say to you, go look at the book. All right, so let's look at number 52. So number 52, they give you guys the x squared plus 2. So let's just grab this out. So go up to 1, 2, x squared. That's going to give you a parabola. Okay, so you're going to have to determine the domain for honors pre-calculus, also the range. Okay, it doesn't say on the textbook. I want you guys to determine the range as well. Okay, so let's look at the domains. I'm going to use this bright green for domain. So if you look at domain, I told you guys the domain is how much ground you're covering. So that's about the x-axis. Okay, if you look at the parabola, it's gonna go up, 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 up. Okay, sideways, endlessly. Okay, so the domain in this case is gonna be all real. Okay, all real numbers. Now let's look at the range. Okay, look at this parabola. It started from a y equals to positive 2. Okay, so your function is going above y equals to positive 2. Of course, it includes the y equals to plus 2. So your range is going to be anything above y plus 2. Well, y equals to plus 2. Sorry, positive 2. Okay, so range is going to be y is greater than or equal to positive 2. Let's move on to the next one. All right, so this is a one that you don't need to graph it. This graph is gonna look a little crazy. Okay, you can definitely put in your graphing calculator and check out how it looks. So this is a rational functions. What you're gonna do here is that for these type of problems, you need to understand that denominator can't be equal to 0. Okay, so if you set the denominator equal to 0, you're gonna get undefined. Okay, back in algebra 2, this is gonna give you something called asymptotes. Okay, what's gonna happen for rational oops, I shouldn't even erase those. Okay, for the rational functions, domain and range are going to be all real numbers except the spot where asymptotes pass through. Okay, so I'm gonna show you guys how to do this one. For the domain, it's gonna be a little tricky here. So domain is gonna be x squared minus 4. Cannot equal to 0. Okay, so let's just add 4 on both sides. So x squared cannot equal to positive 4. So if you square root both sides, so your x cannot equal to positive or negative 2. Okay, which means that you're gonna get asymptotes passing through x equals to positive 2 and negative 2. Okay, so your domain is gonna be all real. So domain is all real, but cannot equal to positive or negative 2. Okay, that's for the domain. Now, the range. It's going to be a little crazy here. All right, so the range. What you're going to do for the range is that you're going to pick the highest degree of the, how do you call it? The numerator, and then the highest degree of the denominator. Okay, so y is going to equal to x over x squared, which equals to 1 over x if you simplify it. Okay, so understand that what happened if I insert infinity or negative infinity into the x. So the denominator gets bigger, this whole entire fraction is going to approach 0. So in this case, 0 is going to be your asymptote. Okay, so your range is going to be all real, but y cannot equal to 0. Moving on. Number 60. So what about this one? I'm going to show you guys on the graph. Okay, first of all, I want to rewrite that as negative x plus 1. Okay, so this is going to be square root of negative x plus 1. And next thing I want to do is I want to, oops, I shouldn't do that. So I want to set this equal to 0. So negative x plus 1 equals to 0. Negative x equals to negative 1. X equals to 1. So you know that this is about to shift towards the right by 1. Okay, so it's the best way to do this is that you set it, you factor out the negative. So it's going to be x minus 1. Okay, so it's probably the best way to do it. Okay, and you know that from here, set equal to 0, well, x equals to 1. Okay, now the graph is going to have a reflection. Here is the reflection. Okay, the reflection is about y-axis because the negative is directly on the x. So it's going to be reflecting over y-axis. Okay, so originally you guys are going to see something like this. Not anymore. It's going to be to the other side. Okay, let me use a different color. So it's going to be to the other side. And it's going to move towards the right by 1. So your starting point, it's going to be x equals to 1. So this is how your graph is going to look like. Now let's determine what the domain is. So let's bring out my green. So the domain is going to be x is less than or equal to, so everything here is my domain, 1. Okay, let's bring out the range. Okay, so the range, it looks like the range is always going to be, it's going to be anything above the 0. So the range is going to be y is greater or equal to 0. Okay, so that's your domain and range. Moving on. Sum difference product quotient of two functions. This is pretty easy actually, not as complicated as the domain one. So basically you guys gonna see what these things happening to the two functions. I'm just gonna show you guys some problems right here. So number 68. So number 68, when you add these two up, what you need to do is see this, add up. Okay, so f of x, oops, sorry, you're gonna have to understand that this is gonna turn into f of x plus g of x. Okay, so which means that already given to you in the or it's already given, right? So all you need to do is add those two equations up. Gosh, I'm getting dizzy, just keep talking. All right, so 2x plus 1, you're going to add to 3x minus 2. Okay, go ahead and solve it. Combine the like terms. That's going to be 5x. So plus 1 minus 2, so that's minus 1. Okay, let's move on with a different color. So this one, you have to multiply the two functions. So that's going to be 2x plus 1 multiplied by 3x minus 2. Okay, so you're going to have to FOIL this thing. You're going to have 6x squared minus 4x plus 3x minus 2. Okay, combine the like terms. It's going to be just subtracting x. Okay, let's move on to the next one. This is the easiest of all. All you need to do is divide one function to the other. So it's going to be 2x plus 1 over 3x minus 2. Okay, let's move on to the next one. So find a difference quotient of a function. Okay, so for this one, it's going to be slightly annoying, not difficult, but just a little bit annoying. So this is the formula that you have to plug in. Okay, so every time when they ask you the difference quotient, like number 82, you're gonna have to put that in. Okay, so let's rewrite that formula one more time. So it's gonna be f of x plus h, and this is a little bit related to the calculus. Okay, divided by h. Okay, hopefully I got the enough space for this. So what I'm gonna do is f of x. Okay, let me rewrite this. Okay, so what you're gonna do is you're gonna have f of x plus h. So what is f of x plus h equal to? So when f of x equals to 3x squared plus 2, what I should do first is rewrite what is f of x plus h. So you're gonna have to sub in x plus h into x. So this is how it will look like. 3, God, I don't have enough space. X plus h squared plus 2. Okay. All right, so let's go ahead and do it. So this one is the f of x plus h. So that will be, I'm just tired to read. Okay, and then f of x is that. So subtract 3x squared plus 2. Everything divided by h. Oops, divided by h. All right, so what you're gonna do next is just do it. Okay, so for the red, I'm gonna FOIL this x plus h out. So that's gonna look like square plus 2xh plus h squared. Okay, do not forget about that plus 2. So plus 2. Okay, I'm gonna remove the parentheses. So I'm gonna write it as minus 3x squared minus 2. Okay, everything divided by h. All right, so the next thing I want to do, oops, wrong color. Next thing I want to do is to distribute the 3. Okay, so it's going to be 3x squared plus 6xh plus 3h squared. Oh, I can cancel out the plus 2 and minus 2. So just write minus 3x squared. Okay, I can also cancel this out. So these are canceled. Everything divided by h. Okay, so you can also simplify the h. So h is going to get canceled. Simplify with h. So left we with just one h. So it's going to be 3h over there. So here is going to be your answer. So it's going to be 6x. Plus 3h. Okay, that's going to be your answer. And that's it for this assignment. God. Finally finished.